Chapter 11, Lists, Tuples, and Dictionaries. Hello everyone, welcome to Chapter 11 of Browning's Introduction to Programming with Python, 5th edition. And this chapter we're looking at some container objects that are really interesting, give you a lot of power and programming capabilities. We've used lists a little bit in the past, but we're going to add to that. So again, these are container objects, or they're objects that contain multiple items that are addressable by a position, be it a name or a letter or a word or a number, an index position. In other languages, this would be referred to as a very large and important topic, something known as arrays. What arrays are is they are sequential areas in memory that typically hold like data. But what we will find with lists, tuples, and dictionaries is that you might consider them more of an enhanced array, and they do a little bit more. But again, an array is a foundational concept in programming, and it's a sequential area in memory that holds like data. So we might have a block of memory addresses from, say, A1 to A15, and they all held character data, or they all held each individual slot, 1, 2, 3, 4, 5, 6, etc. to the end. They hold fractional data, character, integer data, who knows. All right. We did actually allude to this in a previous chapter that strings were really containers in some degree because the characters made up the string and they were addressable by an index position. You recall that we started at the first position was 0 and the last addressable position was 1 minus the length. So again, Chapter 11, these data could be variable. You might think of them as like post office boxes that are addressable. All right, so they're very similar to your regular variables, but the whole area has multiple slots, or post office boxes, memory locations, cells where you can get to this data. All righty, so let's look at lists first, and it sounds like maybe I'm trying to say lisp, as in you have a speech impediment. That is actually not the case. It's lists, L-I-S-T-S, and in fact there is a programming language called Lisp, and it's an AI or artificial intelligence language, very popular. And if you're interested in looking at sidebar information or other things, I would definitely Google up the Lisp programming language. There's another one, Prolog, and some others out as well, but certainly AI is not going anyplace. So if you're a curious soul, look up Lisp programming, and you may want to try your hand at it. But that being said, we're not doing AI right now, we're doing lists. So each element of a list, also known as a sequence, can be individually accessed from the beginning or from the end, or any location that you choose. For example, if you look on the bottom of the first page, we have a list called foo. And then we have the index position, 0, and then the data that it holds, -3. Or, since there are 5 elements in this list, you could also address position -5, which would give you that last, or that first element. Okay? Second position is 1, and it actually holds a 1. Or, we could address it as -4 in this particular case. So again, we start with 0. Last addressable spot is 1 minus the length. So the length is not the last addressable spot. To declare a list or a sequence, foo, square brackets, and then the data we want to put into it as far as numeric data. All right. Looking over at the next page, you will see that we have foo 0 is equal to -3. So really, we're setting data into these individual elements in this list sequence, just like we really would with a variable. We can recycle some knowledge here. In the second position, foo 1, we want to put in a value of 1. Third position, foo 2, we want to put in a value of 43. So just think of it as you're assigning data to a variable just like we've done before. No big deal. You want to print the data that's there, just like you're dealing with variables. Same thing. Print name of the list with the index position that you want to print the individual item from. In this case, print foo 1 would print the second data element, which is a 1. Screen capture there. Hit pause, try that out from an interactive prompt, and then we will resume, and you can see how that works. Alrighty, very good. So we said that you can go up or down a list to access the elements of a list. So a 5-element list, the first would either be a 0 or a -5, depending on the direction that you're going. You use whichever one makes sense to you. From a script, try the next example and you'll see how that works. Note there are comments to kind of explain going up or down a list, and then hit resume when you're ready to move on. Very good. Alright, now that you've read how to implement a list, you may be wondering, how can I get rid of certain items in a list or one of these container objects? Well, the delete command will let you do that. You're going to do del and then foo, in our case our sequence or list called foo, and then the element that you want to delete. If we want to do the second element, we do del foo1. Alright. You can also do slices, because remember there are multiple items in there. So you could say del foo first position :3 to delete from 0, but not including the fourth number 3 element. Alright. Now let's try and move on to other methods you can use with lists. We have the extend, where you can basically add to a list by appending a list to a list. You can insert at a certain point. You can remove at a certain point. You can take an item, pop it off the stack, is what you'll hear referred to, or take it off of the item. Or you can sort the items in the list. So stop at this point and try some of those out on the foo example that you just tried from a script, and then hit play when you're ready to move on. Alright, very good. So let's try an example with pop. Pop, we have x is equal to 1, 2, 3, and 4, and then we print the entire list, and then we're going to take a value off, reprint it, and we'll see that it's removed. Alright, reverse. We're going to make our sortomatic, and we're actually just going to sort the items, and then we're going to reverse them. Try that out and hit resume when you're ready to move on. Alright, X index returns the numeric index value of where it finds the first instance of I. Alright, so this is a bit of searching capability, and the last item we have there is count the number of times or occurrences that I, what you're searching for, is found in X. So certainly it has a little bit of intelligence built into it as well, kind of like the searching and filtering that we've done in previous chapters. Alright, tuples. And I will say that some of the things that we're talking about here, even though arrays are common with other languages, you will see add-in libraries for things like tuples and dictionaries and stuff in some different languages. Like C++ has a tuples library that you can add in, even though it's a more granular language, and typically you might be using just more arrays or array lists. Alright, there's a lot of cross-pollination though between languages. But tuples, very similar to a list, is a data type known as a tuple. A tuple is like a list, only it's non-changeable, or also referred to in Python as immutable. Alright, you designate items in a tuple by separating the items with commas enclosed in parentheses. Items can be character data, strings, numbers. Other tuples, dictionaries, which we'll get to in the next section, start with an ending position of 0, just like we did before. Alright, so again, they're immutable, so they're not changeable, so that's one thing that you want to remember. But let's try for our first example here, because we'll see that we might want to go back and forth and make something changeable or mix things together. We'll convert from a list to a tuple. So we'll make a tuple with cat, dog, and bird, and then we'll print it. Then we'll find the length, and then what we'll do is we'll make a list, and then we'll use our type function, because we did say tuples were a data type. We'll make a new tuple, but note that we're doing that from a list. Aha, interesting. Alright, print it out, use our type command to prove out the data type. Hit play when you're ready to resume. Alright, very good. Challenge. You can also convert from a tuple to a list, so we can go either way. So we have our list and then the tuple name. Instead of tuple and the list name, convert it back and forth. Easy enough. Alright. How do you access data in a tuple? a slight bit more challenging than a list, but for you guys, it's going to be really easy. If we look at the next example, we have T underscore 1 is bird, cat, and fish. T underscore 2, these are our tuples. Sammy Snail, Bill the dog, and then we have another tuple within a tuple. We have a couple of tuples. No, not very funny. But anyways, we print them out, and then if you'll notice, we're doing slicing and we're also doing index positions to access where we are. So try this example out if you would, and you'll see how that works. The last one's kind of cool because we're digging into the second tuple and getting to a specific item in that second tuple within a tuple. All right, where it says cool, print the first letter, the second item, and the third item in T2. Very good. All right, so we've learned a little bit about tuples. Let's look at lists again inside of a tuple. We have our original list. We have tuple 1, which has a value of 1, and then it has the original list as a data element item in there. So keep in mind, we're getting to the items in the tuple, and then if there's a tuple within a tuple, we go into that tuple and then go into the list items in it, or the index positions in that, I should say. Try this out if you would, and then we will look at, when you hit play, more fun with tuples. Very good. More fun with tuples. What else can you do? Well, you can concatenate and join tuples. So what we've done so far is we've had lists and tuples, and we've been putting lists inside of tuples and tuples inside of lists. But we could just say, hey, we have these 3 tuples, we want to join them together. All right. We're using actually the addition symbol, which is common across some other languages too, as an overloaded operator. And what that means is it just does different things based on the context of how it's used. You have 2 numeric values with an addition symbol. It's going to join them together or add them together. If you have strings or tuples or things like that, it's actually going to concatenate or join them, because you really couldn't add them together. There'd be no total value, but you could actually connect them together. So try that out, and then if you would, we'll move on to the next example. Hit play. Alrighty. One of the coolest things you can do with tuples, another handy feature of tuples, is direct assignment. In other languages, if you want to swap A for B and B for A, basically you need a temp variable. You're going to have a third temporary place. So let's assume you want to take A and put it in B and put it in A. Well, you couldn't just do that normally, because if you did, you'd step on the B value before you moved it back to the A position. So you'd have to move it to a temporary holding area. Well, with tuples, you can do direct assignment. You can just literally say swap A for B and B for A, and it'll do that temporary holding for you and do the swap. So as an example, C++, you have to have that third area for a temporary holding slot, whereas with Python and tuples, you can just say, hey, do the old swap-a-rama, and it'll swap them for you. C++ versus Python example is a script. Try that out and you'll see exactly how that works. Hit play when you're ready to resume. Alright. The last thing we'll look at with tuples is unpacking a tuple. And the big thing that you want to have with that, it's a little different than variables we've dealt with before. Typically we've had a variable equals something, and that's how we've worked with them. Alright, well, we know tuples, like lists, have more than one item in them. Alright, so the tuple is going to go on the right hand side. You want to make sure that in order of the variables where you want the data to be extracted to, you have those variables separated with a comma on the left. So for example, in the tuple we have my tuple, and from the old Saturday Night Live skit, Mr. Bill and Sluggo, we have Sluggo, Mr. Bill, and Mr. Hand, which are in the tuple. If we want them in that order to be unpacked into 3 variables, first, middle, and last, we're going to have those in that order on the left, equal sign, tuple on the right. It'll unpack them one at a time. Alright? Try that out from a script and then hit play when you're ready to move on. Next data type we will look at is dictionaries. Dictionary defines a one-to-one relationship between a key, an index, as far as what we've been learning about so far, a numeric value and an associated data value. So, for example, you can have a word or a letter or something, string data, we would say, that might designate the actual data element. All right. Try out the dictionary example where we have 1, and note the quotes around it, for steak, 2 for pork, 3 for chicken, and 4 for fish. And then we'll try printing that out, and then printing out individual elements. And then let's try out a little raw input here for a string, and try and do a little search for something in it as well. So try the dictionary example out, hit play when you're ready to resume. Very good. Delete and clear. You can delete items or clear data items out from a dictionary. DEL. So try that out if you would. All right, searching for data. This is a very important topic, and we could spend a lot of time on this. A little bit to it, but really good stuff. As far as a linear search, we've got a couple of things going on here. We're assuming that the data that we're searching is not sorted. It's not sorted alphabetically, descending, ascending, whatever. And so we have to basically start from the beginning or the end and march through every element until we find what we're looking for with a linear search. Not particularly most efficient. You're looking for something in a book, you have no index, you just pick page 1 and start looking until you find it. If it was a big book, it could take you for a while. All right. With a binary technique that we're going to look at, we have the data sorted, ascending or descending, and basically we can find the midpoint, and then we could say is what we're looking for above or below this midpoint. If it's above it, then we can half the data, get rid of it, find the midpoint again, and then say is what we're looking for above or below the midpoint. And if it's above it, half it again. So you notice there's some great economies of scale there with a binary versus linear technique, but the key with linear is it's not sorted data. So what we're going to do is we're going to try a linear search on unsorted data in a list. We've defined a search function called find it. The big thing you'll need to make sure you do is get your spacing right on this. Remember, Python is sensitive with tabbing, so if this does not work or you get some red squigglies of death, make sure that you get your spacing right. Try that example out, and then what we will do is we will move on to the next example. Alright, search from a list. Let's try another example to search for a word, string, or character data in a list. Has a little bit more Pythonic flair than the last example, but certainly this is interesting where you can search for tennis, golf, swimming, archery. Try that out and then hit resume, and we will look at binary searches. Alright, binary search, as we said earlier, assumes that the list is sorted and finds the midpoint of the list. So you've got to have something that's sortable, so you can actually do that. Determines if the value to be searched for is either before or after the midpoint, at which the point of the list is effectively reduced by half. So you're getting some really good economies of scale here. Alright, again, you need to watch your spacing on this, and the driver code starts at the bottom with my list, and we have a series of numeric values which would be easily sortable. Alright, and then we've come up with our own little search function. So try that out if you would, and then we will move on to the next example. Very good. So the last one that we will try, very similar, binary search. The original example preserved the original index value. A true binary search really wouldn't need to preserve any values because it's just going to get rid of what it doesn't need. So this next version does a binary search to find your value but doesn't really preserve anything. Try that out if you would, and then look at the activities at the end to extend your knowledge, and we will move on to chapter 12, persistent data, when we talk again. Have a nice day.